This video covers how to make a dilution in the event that your test result is too high. In this example, we are using a urine creatinine test. Testing procedures vary by individual test. Please follow your testing procedure.
So this is going to be the procedure for how to dilute a test when you have a reading that's too high to read when we're doing any of our test protocols. So we have our test protocol. We are doing creatinine and we're doing urine creatinines, which are typically high and need to be diluted. We made up our reagents in here with our reagent here. And we already pre-incubated some reagent in the incubator 3 to 5 minutes. We have our sample right here of urine and everything is ready to go. So this is 1 ml of reagent. The sample volume is 50 microliters for this particular procedure. This varies by procedure. So we're going to take 50 microliters of our sample right here, and we're going to add it to the test tube and just add it in here to read. And the test takes about a minute to read, so we're going to wait a minute for it to read. So the reading was too high to read. It put an R by the value, and you can tell, so this was quite dark, much darker than it initially was. And so now what we're going to do is we're going to dilute it so that we can get it in, hopefully in reading range. So we are going to start, so I've got a pipette set 400 microliters. So remember our sample volume is 50, so we'll need to get at least 50 microliters of sample ready. So we're going to grab a tube and I'm going to write dilution. I'm going to make a 1/5 dilution, so I'm going to write 1/5. That way you just want to label them so you know what's what. Okay, so then for a 1/5 dilution, we're going to have 1 part of sample and 4 parts of water. So we're going to do 1 part of sample, so this is 100 microliters right here. Add it to the test tube right there. And then we are going to do 4 parts. I'm going to do it 4 times. It's not usually the best thing to do, but this pipette only goes to 300. So we're going to go 1 part, 2 parts, 3 parts, 4 parts of water, and then give it a shake. Sometimes you can mix it this way if you want. Okay, so this is a 1/5 dilution of our urine sample, and this now becomes our sample. So we are going to take our 50 microliters again, our 1 ml of reagent that hasn't been used here. We're going to take our diluted sample, get 50 microliters of it, and then we're going to add it here, and we're going to read it. And it will take again about a minute to read.
The first sample was too high for the analyzer to accurately measure, resulting in an R indicating it was too high to read. The test requires 50 microliters of sample volume to be read. Therefore, your total dilution volume must be at least 50 microliters. In this case, we used a 1/5 dilution, meaning 1 part sample and 4 parts diluent to make a total of 5 parts. We used 100 microliters of sample and 400 microliters of water, totaling a 500 microliter dilution volume. Once the dilution was made, we used 50 microliters for our new testing sample to add to the reagent. After our dilution, the analyzer was able to determine urine creatinine levels. The results were high, indicated by an H, but were still able to be determined. Notice the color difference in the tubes. The first is our reagent, the second is the sample that was too high to be read, and the third is the sample we used to determine our results. Since we made a dilution, to determine the true results, we must multiply our analyzer result by the dilution factor. Since we did a 1/5 dilution, we must multiply this by 5. If written this way, the denominator is our dilution factor. If written as a 1/4 dilution, still 1 part sample, 4 parts diluent, totaling 5 parts, the sum of the numbers is the dilution factor. We hope you enjoyed this video and it helped to better understand dilutions. Thanks for watching.